So today we will discuss about 2.2.13 packet tracer activity point-to-point single area OSPFv2 configuration. Okay, we have three routers here. We have three LAN here, three WAN here. Okay, three layer 3 switches, three end devices PC. Okay, so there are four steps here. Configure router ID, configure network for OSPF routing, configure passive interface, verify OSPF configuration. Okay. So here, start with part one, configure router ID. You know why we need router IDs for identify the router for the DR designate router election. No, we need router IDs. Okay. So first thing you're going to configure the router ID in router R1. Okay, the router IDs are given as R1 is 1.1.1, R2 is 2.2.2, R3 is 3.3.3. Okay. So go to the configuration mode of R1, configuration mode, then router OSPF process ID. I'll put here 10. Okay, it's given in the question paper. Process ID is 10. Then you have to put the router ID 1.1.1.1. Done. Then go for R2. The router ID is 222, right? Same process ID. So go to enable configure mode. Then router OSPF 10. Then router hyphen ID 2.2.2.2. Then after that go to R3, the process ID, sorry, router ID given as 333, same process ID. So enable configure space T router OSPF 10, then router ID 3.3.3, done. After that, configure the network for OSPF routing. Okay, how many statements are required to configure OSPF to route all network to R1? So here R1, no, you know what is the question? How many statements required to configure the OSPF to route the networks? Okay, so you know OSPF is a dynamic routing protocol. It will whatever routes you know, if the router knows, it will forward or share to other routers. Okay, so what we need is we need to add the network statement for each network which is directly connected to that router. So for R1 we have three direct network 192.168.10.0 and 10.110/30 10.114/30. So how do you know this is direct network? Because this is connected by a direct cable and we configure the interface with the IP address. That's why this is a direct network. Okay. So how do we configure this one? I'll go here. Before that, what I need now for the OSPF network configuration, we need wildcard mask. The syntax is network address, then wildcard mask and area number. Okay, so what is wildcard mask? Opposite subnet mask. Opposite of subnet mask is wildcard. Okay, so here, how do we identify the wildcard mask for /24 and /30? Okay, I have the table here. How to find wildcard mask from given subnet mask? So subtract the total decimal subnet mask from 255. Okay, for 255 units. So here, example /24 means 255, 255, 255, 0. What is the wildcard? This is a wildcard. Okay, what is the wildcard for this 24? How do we get it? Subtract 255 four times from this 255, 255, 250. So when we subtract 255 minus 255, 0. 255, 255, 0. Again 255, 255, 0. Last one 25 minus 0, 255. The answer for wildcard mask for /24 is 0.0.0.255. Now if it is /30, the wildcard mask will be 0.0.0.3. So how you found out? You know the first thing is subtract 255, 255 this one. Okay, with the subnet mask. So subnet mask we have /30 prefix, right? How the /30 will become 255, 255, 255, 252? See, /30 means 24 plus 6, right? So 24 is, /24 means 255, 255, 255. Last one, 6 bits. This 6 bits, how we get is 128 plus 64 plus 32 plus 16 plus 8 plus 4. All those network bits, their values we'll add and we'll get 252. That's why it is 252. So when you subtract this, we'll get 0003. Okay. Now I'm going to create the network for R1. Okay. Inside this one, I'll type network. What is the first network I have? 192.168.10.0. Okay. So here also you can take that. Okay. /24. So for R1, right, 192.168.10.0 space So wildcard mask for 24 is 0.0.0.255 area 0. Done. Now next is 10.1. This is IP, but I need network 10.110/30. Okay. So here network 10.1.1.0 space for 30 wildcard is 0.0.0.3. Okay. Area 0. Done. Then 10.114/30. So same command, I'll just take the same command by pressing up arrow in the keyboard. Then this one 10.1.110 change to 10.114. Then same wildcard mask because it is /30. Done. This is 33 now. After that, what I need if any error happens, no, you have to give no followed by the command. If any command is you type my mistake means put no in front of the command, then the command will be deleted. Okay, maybe you might make mistake in the network address means no need to worry. How do we delete? Put no in front of that command. No in front of this command, you will get the revert back. Okay, I have to give it again. Okay. Now configure network for OSPF routing using interface IP address and quad 0 mask. Okay, what is interface IP address on R2? Okay, so in R2 we have how many IP addresses? For each interface, 0 we have this interface, this IP, this mask. For S10, I have this IP, this mask. For S011, I have this IP, this mask. So here, I am going to configure the router or OSPF commands by using not the network. I am going to give the interface IP address. So IP address means it should exactly match. So the subnet mask will be all 255 because I need to exactly match IP. No? So 255, everything will be 111. So 255. So everything is while subnet mask, everything is 255 means wildcard will be. So if it is all 255 means wildcard will be all 0. All 0 means quad 0. Quad means 4. So 1, 2, 3, 4, 0. Okay. Why? Because interface I want to match the IP address. So matching the IP address means exactly same number. So subnet mask will be all 255. Okay. Now I will do that in R2. I'll go here in R2. The topology here. Okay. So this is my first IP. Okay. 20.1. So I'll go here and I will type network. Okay. 192.168.20.1 space 0.0.0 quad 0, right? Then area 0. What happened? Why it is not coming? Oh, sorry, Mr. I put this in R3. I should put in R2, right? So I put in R3. So how do we delete this? Okay. Same command, up arrow. What I will do? Put no, we deleted. Okay. Now go to R2 because in the question they told R2. So now I'll type the same command. Network 192.168.20.1. So why? Because for R2 G0 this IP. Okay. So wildcard is 0.0.0.0 because quad 0. I need to exactly match that IP. Then area 0. Now it's increasing. Okay, now next IP address is 10.112. Okay, so same I will just use up arrow, many all same, right? So I'll go here 10.112. 10.1.1.2. Done. Next 10.119. Okay, same thing. We'll just type here for more time. Done. 50. After that, configure OSPF routing on router interfaces. Okay, we have to configure the interfaces of router R3 with OSPF commands. Okay, so how I do this? Go to router R3. Okay, how many interfaces we have for router R3? G0 bar 0, S0 10, S0 Okay, so go to R3. Okay, here I want to type what is the command mentioned here? IP OSPF process ID 10. Okay. Before that, you should enter the interface. Okay. How many interface I told? G0 bar 0 first. Okay. G0/0/0. Then what should I type the command? IP OSPF 10 area 0. Now the same thing for interface SE010. Okay. IP OSPF 10 area 0. What is 10? Process ID. Okay. Exit. Do the same for third interface of R3 0 1 1. Sorry. Int serial 0 1 1 IP OSPF process ID 10 area 0. Done. Okay. Now, why we did this? To configure the OSPF should be configured to the interfaces of R3. So R3 has G0 bar 0, S010, S011. So we give each, go to each interface, assign that IP OSPF process ID, area number. Okay. Now passive interfaces. Passive interface means, see, these routers are an OSPF. No, OSPF means they will find the best route by using link shortest or link state of the link. Okay. So link state advertisements are sent between each router. Okay, each router will send other router the link state advertisements. Okay, actually this advertisements, link state advertisement should be sent between routers. So it should be sent between the serial cable. Why should we send this to LAN ports? There is only switch and PC. So we want to stop this link state advertisements to be sent to the LAN port. So what should we do? We have to make these LAN interfaces as passive interfaces. Okay, so this one passive, what is this? G0 bar 0. This also R2 has this one LAN is G0 bar 0. I'll check this options preference and I'll show you. Always show port label. You can see from R1 towards LAN, the interface is G00. Make this passive interface. No need for that interface to receive the LSA, link state advertisements. Okay. Also R2 LAN port is G0 bar 0, G000. Make this passive. R3 also LAN port is G000. Make this passive. So go to R1 first. Okay. Go to R1. Okay. Passive. Passive interface. Then G0/0/0. So the same for R2 and R3. R2 also passive interface giga 0000. Go to R3 also same giga 000 is passive interface. Okay, make this passive. Passive. Okay, I think another mode. Okay, go back here. Router OSPF 10. Now passive giga 0000. This should be done only inside a router OSPF cross ID command. Okay, done. 100%. Now, how do we verify the OSPF configuration? Okay. So commands are there. Okay, we'll go for first show run. You can see that interface 0 bar 0, I give OSPF 10 area 0. Okay, that is done. Serial ports are there. OSPF3. I put interface, I put that one. Now, passive interface is 0 bar 0. Router ID is 333. Okay, adjacency is formed. Now, another configuration command is show IP OSPF neighbor. So here we can see which one is this one. Okay, what are the neighbors? Okay, full adjacency is formed. Okay, then show IP root. You can see the OSPF roots here. Okay, O means OSPF roots. C means direct network. L is the IP address configured. Okay, like that you can see this in all the routers. Okay, so different OSPF commands show IP OSPF and check this board router database interface neighbor everything. Okay, that's what about 2.2.1.